So this is Vaishnav. So,
Yes, Vaishnav.
sir, this is an unplanned journey, sir. I am in my relative's house. I don't have any materials. Can I take the screenshots of what you'll be
Okay.
teaching?
Okay, no problem, no problem.
Thank you, sir.
Okay. Fish. Hello. Am I audible to everyone? Razan? In last class. Yes, Razan, what we done in last class?
Sir, we did the integration part and some questions.
Integration or differentiation?
Integration.
Integration. What was the last question?
We were doing some questions like pi is equals to 0. That's the last thing we did.
Pi is equals to 0. So it must be differentiation of pi would be 0.
Oh, yeah, it's differentiation actually. Okay. Okay.
Just read before that. Razan,
Yes, sir.
just read before that question. What was the previous of that?
1 by x square, and then the answer was negative 2x minus 3.
Okay. So it must be differentiation. Akash, are you there?
Yes, sir.
Okay. So do you have any idea about differentiation?
Sir, no, not really.
Okay. Differentiation is nothing but simply a process of breaking down of a curve to define instant nature of curve, slope, tangent, rate of change. These are something application of that. For this, you have to define if you have x raised to n, and while differentiating it, d over dx defines you nothing but differentiation of this particular function with respect to x. So it will give you nx raised to n minus 1. So this whole term is nothing but an operator, which on operating with this term will give you this part. Likewise, if you have 2 and 3 as two numbers, and if there is operator like plus, so your answer would be just 5. So you can call this term as plus or sum operator, which acts on between two numbers and sum up them to give you just 5. Similarly, d over dx is nothing but an operator, which on operating on this term to convert this function like this. Is it clear? A little bit?
Yes, a little bit, yeah.
Okay. So now we have to use this formula to define some functions. Okay. In last class, we did some small term like single term differentiation. Today we have to define differentiation for sum, difference, multiply, divide. Like we have to define differentiation for operation. First, if you have y is equals to fx plus or minus times gx. So we have plus or minus in between two different functions. So according to rule of differentiation tells you differentiate at first term. Yes, Mikhail.
Sorry, sir. I don't know, sir. Always there's some problem. I am not able to join fast. So can you show what you did?
We have just started this. Okay. So differentiation of first term plus minus differentiation of second term. And there is no impact of first function on the other and other on the first. We have to differentiate each term individually. Now, according to this, I'm using it. Suppose y is equals to x square plus. Now we have to apply differentiation for this function. So we have two different terms. First of all, we have to write each term in exponential form. So you can write it as x raised to 2 for first part and x raised to 1 for the second part is equals to y. Now apply this rule. According to it, differentiate each term individually and there should be plus sign in between. So it will be d over dx, differentiation of first part, that is x raised to 2, plus differentiation of second part, x raised to 1. It is just similar as this part where n is equals to 2 for the first and n is equals to 1 for the second. Now we have to apply this formula. So it will be n x raised to n minus 1 plus for the second part it will be n x n minus 1. So on simplifying you will get 2 times of x to the power 2 minus 1, which is just 1. Similarly, 1x raised to 1 minus 1 will give you just 0, and if x raised to 0 it will be just 1, so it will be 1. Is it clear?
Yes, sir.
Akash, Nabila, is it clear?
Yes, sir. Good evening.
Now we have some other rule regarding it. Next is called product rule. Suppose if you have y is equals to fx multiplied by gx, two different functions and they are multiplied with each other. Now, according to differentiation, it will be dy over dx. Just differentiate first part, that is fx, multiply it by second part, that is gx. So there is, it is depending term, plus differentiate the second part, that is gx, and multiply it to the first, that is fx. So this rule is called product rule, which is defined for two functions related by multiplication or product. In this, just differentiate first part, multiply it by second, differentiate the second part, multiply it by first, and there should be plus sign in between. So this is called product rule or multiplication rule. I'm using a formula or question related to this. If you have y is equals to x cubed times sine x, we have two different expressions. First is x cubed and second is sine x, and they are related by product or multiplication in between them. So according to the above rule, it can be written like d over dx. Differentiate it first part, that is x raised to 3, multiply it by second, that is sine x, plus differentiate second part, that is sine x, multiply it by first, that is x cubed. I've just put all the values according to this formula. Now we have to apply for each part. First is x raised to n, which is just similar to this, where n is 3. So according to the formula, it will be n x raised to n minus 1. And we are differentiating just this part only. And sine x is just multiplied with it. So keep it as it is. Plus differentiation of sine x gives you cos x. It's just a formula. So it will be cos x. And keep this outside term as it is. So just simplify it. You'll get 3 times of x squared times sine x plus x cubed times cos x. So this will be a final result. Is it clear to everyone? Product rule, question rule. Raza,
Yes, sir.
is it clear?
Sir, I wanted to ask that cos, like, where did it come from? The
I
cos.
think I've defined formula related to some trigonometric part.
Right.
Let me revise you. Just 1 minute. If you have y is equals to cos x, y is equals to sine x. So dy dx will give you just cos x. If y is equals to cos x, differentiation of this part will give you minus of sine x. If y is equals to log of x, so its differentiation would be 1 over x. And if y is equals to e raised to x, so its differentiation would be e raised to x. Is it clear?
Yes, sir.
Nabila, in doubt?
No, sir.
Akash, is it clear to this part?
Yes, sir.
Okay, just write it down.
Done, sir.
Vaishnav, have you written?
Yes, sir.
Nikhil, done?
Yes, sir.
Akash,
Yes, sir.
okay. I'm giving you some problem regarding it. Try to simplify it. If y is equals to root of x plus x cube plus 4, find dy dx. Y is equals to x squared times cos x. Find dy dx in each. Here we have 4, which is just a constant term, and differentiation of any constant term will give you just 0. Try to simplify it. In first part, try to write each term in exponential form. First is root of x, which can be written in terms of exponential as power half. Next is x raised to 3, and next is just 4. So according to the rule of differentiation, dy dx is equals to differentiate first part x raised to half plus differentiate second part x raised to cube and differentiate third part just 4. Just apply the formula x raised to n. On differentiating it, it will give you nx raised to n minus 1. Try to simplify. Any problem to any one of you? Please ask. Raza, any doubt?
No, sir.
Akash,
Sir, I haven't found the answer. Can you explain the one more time?
Yes, sir.
in first part we have x raised to plus half. So x to the power n, according to this rule, So n would be just half. Okay. So apply the formula. So you get n x raised to n minus 1 for the first part. Is it clear?
Yes, sir.
Similarly, on applying for the second part, we have x raised to 3. So n would be 3. So n x raised to n minus 1. Is it clear?
Yes, sir.
Third is just a constant term. And I have defined you for any of the constant term on differentiating, it will give you just 0. So it will be 0. Is it clear?
Yes, sir.
Now just simplify it. You will get your answer. Is it clear, Nikhil?
Sir, can you explain the last one again, sir? How it became 0?
Since the last term is 4, which is nothing but a constant term, and I have defined you for any of the constant term, its differentiation would be 0. That's why differentiation of 4 would be 0.
Oh, yes. Okay.
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 Simplify it and similarly try to solve for the next part using product rule. On simplifying, you will get half x raised to half minus 1. It will be just minus half plus 3 times x raised to 2. Now we have x raised to minus half. So move this term to the denominator. Its exponential will become plus half. So it will be plus half times 3 times x squared. Plus half is nothing but square root. So it will be written as 2 root of x plus 3 times of x squared as your final answer. Is it clear to everyone?
Clear, sir.
Nabila, have you got this?
Yes, sir. I
Good.
mean, it's clear.
Good, Raza. Try to solve for the second using product rule. In second question, we have x squared times cos x, two different functions, and they are related by product. So use product rule, which says differentiation of first multiplied by second plus differentiation of second multiplied by first. Now apply the formula and try to simplify it. Nabila, have you solved?
No, sir, I'm solving.
Okay. Just differentiate this part, keep this as it is. Similarly, differentiate this part, keep this as it is. Akash, have you done this first part?
Yes, sir.
Nikhil, just check your answer in the second part. Yes, Akash. We have in first part differentiation of x squared. So according to this rule, what it would be?
So is
It
it
would be
2x raised to
good. 2
2x?
minus 1.
Yeah, it'll be 2x, right?
Good. And cos x would be just multiplied with it. Plus differentiation of cos x would be
Minus sin x.
good. And keep this part as it is. So your final answer would be 2x times cos x minus x squared times sin x. Is it clear?
Yes, sir.
Good, Nabila. Now here we have 2x and cos x. This x and this x won't be multiplied together. It will be just as it is to one side and this will be as it is to the other side. These are two different terms which can't be made together or combined together. Okay, Nabila? So these two would be written as it is. They won't be made to combine together. Okay? Vaishnav, have you done this?
Sir, I have a doubt. Can you explain how the cos x changes to minus sin x again?
Differentiation of cos s according to this rule, the second rule. If you differentiate cos x, it will give you minus of sin x. That's why I define it. Differentiation of cos x is minus sin x. Okay?
Okay, sir, understood.
Good. Nabila, is it clear? Vaishnav?
Yes, sir.
Okay. I'm defining the last part of this differentiation. If you have y is equals to fx divided by g of x. Two different functions and related by division. So
1 minute, sir.
it
Can you
will
show
be-
the previous slide? 1 minute. Thank you, sir.
So according to this rule, it will define you differentiate first part, multiply it by second. Similarly, differentiate second part, multiply it by first, but put a negative sign in between and whole divide by square of denominator. So this is the rule of division, or you can say it is quotient rule. I'm giving you one problem regarding it. If you have to find y is equals to tan of x, and you have to differentiate it. We don't have any direct formula of differentiation of tan x directly, so we can break this part into sin x divided by cos x. Is it clear? Now we have both numerator term as well as denominator term, or you may write it as sin x divided by cos x. Raza, is it clear?
Yes, sir.
Now apply the formula dy dx is equals to differentiate its first part, that is sin x, multiplied by second, that is cos x, minus differentiate second part, multiplied by first, and whole divided by square of denominator, that is cos x. Is it clear? Akash, any doubt
No,
till this
sir.
part? Okay. Just write it down and try to simplify it. We have formula for differentiation of sin x. We have formula for differentiation of cos x. Put all the values and try to simplify it. Raza, just check your calculation. Yes, we have sin x. Sin x divided by cos x. Raza, just check your calculation. Nabila, just check your calculation. Nabila, I think the answer is correct, but we'd like to answer in some sec or other term other than tan. Just convert your formula or convert your answer in terms of sec.
Okay, sir.
Good, Mikhail. Try to convert it in terms of sec. Yes, Nabila.
Sir, I converted my answer to tan, right? So should I convert it to cot, because I don't know how to convert it to sec?
Sec squared theta is equals to 1 plus tan square theta. Okay.
Oh,
So I think your answer would be like this. So you may write your answer as this.
okay,
Okay.
sir.
Nikhil, you also got the same answer?
Yes, sir. Yes. I'll convert it, sir.
Akash, any problem while solving?
Sir, I didn't get the answer, sir. Can you explain?
Okay, just 1 minute. In first part, we have differentiation of sin x. So differentiation of sin x would be cos x multiplied by cos x. Is it clear?
Yes, sir.
Minus differentiation of cos would be minus of sin x and multiplied by sin x whole divided by cos x squared. So cos into cos will become cos square x minus minus plus sine into sine becomes sine square x and whole divided by cos square x. Is it clear?
Yes, sir.
Now this numerator is nothing but sine square x plus cos square x. I think you must have learned in class 10 its value would be just nothing but 1. Okay? Sine square x plus cos square x would give you nothing but 1 divided by cos square x, and 1 over cos would give you nothing but sec square of x. Is it clear to everyone? Is it clear to everyone?
Yes, sir.
Akash, is it clear?
Yes, sir.
Or you may define this like this cos square x would be in division with this part as well as this part. So you will get cos square x divided by cos square x plus sin square x divided by sin cos square x. So cos and cos would cancel out, so it will be just 1, and sin over cos would be tan square x. I think Nabila and Nikhil have done this part.
Yes, sir.
Okay.
Yes, sir.
Vaishnav, is it clear?
Yes, sir.
Okay. Just write it down. Have you all written?
Sir, 1 minute.
Done, Mikhail?
Yes, sir. Done.
Okay. I'm giving you one problem regarding this. If you have y is equals to sec x and you have to differentiate it. So first of all, you write this down as 1 over cos x. Now apply the formula of division or quotient formula. We have 1 in numerator and cos x in denominator. Try to find dy dx. Just use 1 as numerator part and cos x as denominator part and apply the quotient rule. Try to simplify it. Just apply the respective value at the respective position. Good, Mikhail. Move your denominator to numerator. Akash, any doubt?
Sir, I haven't gotten it, sir.
Okay. In numerator, what we have?
D by dx into 1.
So it will be 1, and in
Cos-
denominator we have
cos
cos x.
2x.
Similarly, in second part, here would be cos x, and 1 would be at this point, and whole divided by cos of x squared. Okay. Just tell me, 1 is a constant term or a variable term?
So constant term.
And differentiation of any constant term would be nothing but
1.
0.
Oh, so it's 0.
0. And
Okay.
0 multiplied with all numbers would be 0. So it will be 0. Is it clear?
Okay, sir.
Similarly, differentiation of cos x would be minus of sin x, and whole divided by cos square x. You may write it as cos x into cos x. This minus and this minus would become plus. You may write 1 into sin x divided by cos x times cos x. This whole term will define you sum of the trigonometric function. 1 upon cos x would be sec x, and sin x upon cos x would be tan x. Is it clear to everyone? Raza, is it clear?
Yes, sir.
Vaishnav? Nabila?
Yes.
Yes, sir, it's clear.
Good. Just write it down. Just wait for 2 minutes, okay? Okay, we have just finished all different part of differentiation. Now I'm defining application of this differentiation, how to define it. We have some application of differentiation. First is this differentiation would simply define you slope or inclination of any line with respect to x-axis, or you may call it as m is equals to tan theta. Next, it will define you tangent to the curve. Next, it will define you rate measure. Next, it will define you instant nature of curve at any instant. And last, it will define you maxima or minima of a particular function. Is it clear to everyone?
So what is the third point?
Rate measure. Rate measure means change of a quantity with respect to other quantity. Okay.
Okay, sir.
I'm defining the first part. If you have to calculate slope, it means tan theta. Let's say if you have a curve like this, now if you draw a tangent to it, let's say this point. So this tangent must be inclined at some theta with respect to horizontal, or you call it as x-axis. So this inclination of this line with respect to x-axis, let's say theta. So it is defined by this differentiation. So dy dx means differentiation of y with respect to x. It will define you nothing but tan theta to this particular curve at this given instant. There will be a problem like if you have y is equals to 1 over 2x square, then they will ask you find theta at 1, 1 coordinate. So to find theta at this particular point, we have to first differentiate this term. So let's say dy dx is equals to half being constant. So take it outside as coefficient. Next is x raised to 2. So according to the formula of exponential, it will be nx raised to n minus 1. Now this particular dy dx will define you nothing but tan theta according to this concept. So put it to tan theta is equals to 2 and 2 would cancel out. So you will get x only. Now here we have only x which having value as 1. So put it. So it will be 1. Now equate to tan theta. Tan theta is equals to 1. So theta would be equals to 45. Like this, you will find theta to any particular curve at given instant or coordinate, according to the formula or according to the problem. Is it clear to everyone?
Yes, sir.
Akash, any doubt?
No, sir.
Okay, just write it down.
Sir,
Yes, Nikhil. Hello.
Sir, okay. Last part again, sir.
Yes. Last part, this
But
part.
no, sir. The tan theta is equal to x is equal to 1. So how did you get that?
We have to find theta related to this particular curve at this particular coordinate. Okay. So if you have to find slope, inclination, theta to any particular curve, so simply differentiate that particular part. So it will be dy dx is equals to this part. Now dy dx will simply define you nothing but tan theta. Okay. And this 2 and this 2 would cancel out. So you'll get x only from this simplification. Okay. Now, according to the problem, here we have given 1 and 1, means coordinate of x is 1 and coordinate of y is 1. But in this expression, there is no any y, so we have to put the value of x only. Okay.
Yes, sir.
Now, on putting the value of x, which is nothing but 1, you will get tan theta is equals to 1. Now, if tan theta is equals to 1, so theta would be just 45 degree, as tan 45 degree is equals to 1. Okay.
Sir. Yes, sir. Understood.
Vaishnav, is it clear?
Yes, sir. Clear.
Now, next part is to define tangent to the curve. So tangent is a line which touches the curve at a single point. That's why I have drawn a single line to this particular curve at this particular instant. Third is called rate measure. Rate measure means change of a quantity with respect to some other quantity. For this, I'm giving you one problem. Let's say if we have if volume is equals to any volume of any sphere is equals to 4 by 3 pi r cube. So they will be asked to find a rate of change of volume with respect to its radius. So according to the question, it would be if a balloon filled with air is expanding, find change of volume with respect to radius at r is equals to 2 unit. Is it clear? So we have a problem in which a balloon is filled with air which is expanding. So we have to find change of volume with respect to its radius. As we have a formula, volume of a sphere is 4 by 3 phi r cube. I have assumed this balloon to be spherical in shape. That's why I have defined volume of sphere here in terms of radius. 4 pi is nothing but a constant term, so keep it as it is. And we have to differentiate this volume, which is depending upon r. So differentiation of volume with respect to r would be equals to 4 by 3 pi as constant. Take it outside. And here we have r raised to cube. So according to formula, it would be nx raised to n minus 1. Is it clear to all till this part?
Yes, sir.
Akash?
Yes, sir.
Okay. Now, if you further simplify it, you will get dv over dr is equals to this 3 and this 3 would cancel out. So you'll get 4 pi and r is to just 2. Now we have the value of r as 2. So put it here, you will get 4 pi into r squared. So square of 2 would be 4 into 4. You will get 16 times pi is equals to dv by dr. So dv is nothing but change in volume and dr is nothing but change in radius. So in total, it will define you change of volume with respect to change in radius. Is it clear to you all? Nikhil?
Yes, sir, clear.
Good. Just write it down. Have you all written?
Yes, sir.
Vaishnav?
Yes, sir.
Raza? Have you done?
Yes, sir.
Good. Next is instant nature of curve. For this, I'll define you in third chapter how to calculate this part. In this part, I will define you the last part, which is how to calculate maxima or minima of a function. So next is maxima or minima of a function. Suppose if you have a curve like this. This is your y, which may be written as fx. And this is your x. So from this, if you differentiate this particular y 1 times, so we can call it as first derivative. First derivative means differentiation of that particular function just as 1 time. So it will be written as dy over dx. This particular term on the basis of graph will define you tangent to that particular curve at any instant. So simply this particular term graphically represents you tangent to the curve at any instant. In terms of calculation of slope, this will define you tan theta at given instant. So if I draw tangent to this particular curve, let's say at this point. And similarly, at this point. Now, this point will be nothing but highest and lowest correspondingly related to this particular curve. Is it clear? Nabila, is it clear?
Yes, sir.
So this point will be the highest point and this point will be the lowest point related to this particular function. So we can call it as maxima or maximum value, or it will be minimum value related to this. Now, if we differentiate this function again, so we can call it as second derivative. Just 1 minute. Now, if I ask you to define this particular blue line inclination with respect to x-axis, so what will be your answer? Raza? What is the inclination of this blue line with respect to x-axis? Are they parallel or not?
Yes, they are.
And for any of the two lines that is parallel, their inclination would be? Nabila, if two lines are parallel, then their inclination in between them would be? Akash, inclination between any two parallel line? It would be 0, okay? So we can say this line is parallel to this, so the inclination of this line with respect to x-axis would be 0, or we can call it as theta to be 0, so it means tan theta would be 0. Similarly, this line is also parallel with this line, so we can call it as its inclination with respect to x-axis would be 0. Now, what is this particular line or this point and this point is defining you? This is nothing but maximum or the highest point, and this is minimum or the lowest point. So from this, you can conclude for maximum or minimum, as their inclination with respect to x-axis would be 0, it means the differentiation of function at that given instant would be 0. So if you have to calculate maximum or minimum of a particular function, just differentiate it and put it to 0. So from this, I'm concluding if of a function if you have to find maximum or minimum value of a function, put dy dx to be 0. Is it clear to everyone?
Yes, sir.
Akash, is it clear?
Yes, sir.
Now, if you put this differentiation to be 0, you will get two different values, either maximum or minimum. Now, our next question is how to define whether it would be maximum or minimum. So to check this, I'm defining you the second derivative test. Second derivative test. It means you have to differentiate that given function twice. It means differentiate it again. So in second derivative, d and d on multiplication would become d2y and dx would become dx squared. So this is second derivative of that given function y. Is it clear? This is just notation of second derivative or differentiation 2 times of the same term. Nikhil, is it clear?
Yes, sir.
Vaishnav, is it clear?
Yes, sir.
Now, this second derivative will define you nothing but tangent next to the dy dx. I'm explaining you. This term will define you tangent next to dy dx. It means initially we have this point as dy dx. So after it would be at this point, or for this part, after it would be at this point. So if you plot or if you draw a tangent to this curve at this instant, you will get this line. Now, if you plot tangent to this curve at this point, you will get this. Is it clear to everyone?
Yes, sir.
So this blue line is defining nothing but dy dx, and this black line is defining you nothing but second derivative, that is d2y over dx squared. Now I have to define the inclination of second derivative with respect to x-axis. It means with blue line. So if you calculate it from this, you have to move in clockwise direction, and for this you have to move in anti-clockwise direction to reach at that given line. Now for the calculation of angle, if you move in clockwise direction, it will define negative value, or if you move in anti-clockwise direction, it will define you positive value. So from this you can say this angle would be negative and this angle would be positive. Is it clear to you all?
Yes.
Nabila, is it clear?
Yes, sir.
Now from this you can say if second derivative is positive or if second derivative is negative. Let's say for this point, second derivative is positive and it is defining you nothing but the minimum value. So we can say if second derivative is negative, then the function at that given instant would be minimum. And if second derivative is negative, let's say at this point, the function would have maximum value at its point. So it will define you maximum value. Is it clear to you all?
Yes, sir.
So for this entire path, you have to do two things. First, differentiate the function and put it to 0. It will define you point of minima or point of maximum. So on putting the first differentiation of the function to 0, you will get value of x. Value of x for which the function would be at maximum or it would be at minimum. Let's say x1, x2. Now we have to differentiate this term again, that is called second derivative. It will actually define you whether the function would be at maximum or be at minimum at that given corresponding value of x1 and x2 respectively. Is it clear?
Yes, sir.
Okay, just write it down. I'm giving you an example related to this to define you all. Have you all done till this part?
Yes.
So one minute, sir.
Okay.
Okay, sir.
Vaishnav, have you done?
Yes, sir.
Okay. I'm defining you using a problem. If y is equals to 8 plus 4x minus x squared. From this, you have to find y minimum or y maximum. So first of all, just differentiate it and put it to 0. Try to solve. Differentiate this function and put it to 0. Bila, have you done?
No, sir.
You have to differentiate this function. So dy dx is equals to Akash. Here the first term is 8, whether it is constant or variable.
That's constant.
So its differentiation would be
0.
good. 4 is a constant term, take it outside as coefficient. X raised to nothing but 1. So on differentiating it, you will get 1x raised to 1 minus 1. According to the formula, if you have x raised to n, and if you have to differentiate it, you will get nx raised to n minus 1. Similarly, in the second part, we have x raised to 2. So according to the formula, nx raised to n minus 1. Is it clear?
Yes, sir.
Nabila? Okay, just
Yes,
simplify it. Just simplify it and put it to 0. You will get the value of x. Just equate it to 0 to get the value of x. Okay, Mikhail?
Sir, I didn't understand, sir. What do we have to do?
Just equate the expression, what you got for dy by dx, and put it to 0. From here, you'll get the value of x. Nabila, just check your calculation.
Yes, sir.
Razan, just check your calculation. I think it would be in positive. Good, Mikhail. Akash, have you solved?
Oh, no, sir.
On simplifying this, you will get 4. X raised to 0 is nothing but 1. So it will be 4 minus 2x. Just put it to 0 and try to solve for x from here. Vaishnav, just send your answer. Good, Nabila. So if you simplify it, move this minus 2x to the other side, it will be 4 is equals to 2x. To move to the other side, it will be 4 over 2 is equals to x. So you'll get x is equals to 2 from here. Now, the next part is to define whether this value would have maximum or minimum value of y. As we have dy dx is equals to 4 minus 2x. So we have to differentiate it once more. So it will be second derivative. In the first part, we have 4, which is nothing but a constant term. So its differentiation would be 0. In second term, we have minus 2 as coefficient. So take it outside. x raised to 1. So using formula, it will be 1x raised to 1 minus 1. So on simplifying, you will get just minus 2. Is it clear?
So
Yes, sir.
Akash, tell me about this, whether it is in negative or positive.
what's it?
Using this particular term, whether it is in positive or negative.
In negative.
So from last part, if second term is, or if the second derivative of the function is going to be negative, so it will define you nothing but maximum value of y. So from this, you can say your second derivative is negative, so it will define you maximum value for y. So y maximum at x is equals to 2. So it will be 8 plus 4 into 2 minus 2 squared. So you will get 8 plus 8 minus 4, 16 minus 4, or it will be 12. So the maximum value of this particular function is 12. I'm defining you the graph of this particular problem, the graphical representation. It would be like this. So this is y, this is x, and this is your maximum value of y at this particular coordinate of x, which is nothing but 2. So at x is equals to 2, y is going to be maximum and its value is 12. Is it clear to you all?
Yes, sir.
Yes.
Nabila, any doubt?
So in the first line, y maximum is equal to 8 plus the is the y into 2.
No, I've just put the value of x to 2 in this first expression. So we have 4 into x.
Oh, okay, sir.
So it is just 4. Vaishnav, is it clear?
Sir,
Yes, sir.
sir, we got the value -2, right? So then why did we put as the value of x as 2?
This is nothing but the value for the second derivative of the function, which will define you nothing but whether you get maximum value or minimum value of the function. So this will define you about the maxima or minimum of the function. Okay. In the first part, while differentiating the function and put it to 0, you will get this x is equals to 2. This particular point will define you point of maxima or minima. Like in this part, if at this particular point, let's say x1, graph has its maximum value. So we can say x1 is point of maxima or point of maximum value for y. But the value of y at this x1 would be at this point. So this will be your y maximum. On putting the value of x to be x1 in the expression of y, you will get y to be maximum. But for this part, it will define you nothing but point of minimum value of y at x is equals to x2. So if you put value of x to be x2 in the expression of y, you will get this value to be y. Is it clear now?
Sir, so if it was a minimum value, then what we would have done?
In this particular part, you get just one value, as this particular curve has only one peak, which is this much. Okay. If you increase this particular curve, it will move like this to minus infinity. Okay.
Yes, sir.
So on differentiating the function one times and put it to 0, you will get the value of x to be point of minimum or point of maximum. So to define it, whether it would be maximum or minimum, you have to differentiate the function once again. That is called second derivative. Second derivative is just a check to define the function is going to be maximum or minimum. Okay, so this is not the value of the function to be maximum or minimum. It will define you nothing, but a check of the function is going to be maximum or minimum. So to find the value of y, you have to put the value of x is equals to this in this first expression. Is it clear, Nikhil?
Yes, sir. Understood.
Any doubt to anyone of you? Nabila?
No doubt, sir.
Have you all written this?
Yes, sir.
Yes, sir.
Good. I'm
So-
giving one last part. If y is equals to,
No, sir. Can you show it for 1 minute, sir? Okay, sir.
differentiate it and put it to 0, you will get the value of x to be minimum or maximum value of y. Differentiate it again to define whether the function would have maximum value or minimum value. Yes, Akash, just 1 minute, this last problem. Or you'll do it in homework. Okay, Nabila? Just
Okay,
write it
sir.
down and try to solve it at homework. We'll do it in next class, I think integration, and then with logarithmic function and exponential function. Okay, then we will finish this whole entire part. Then we will start third chapter, that is motion straight line.
Okay, sir.
So do you have any doubt from today's class to anyone of you?
No, sir.
No, sir.
Okay,
Sir, how much
Okay,
of this
then.
chapter is over?
I think we have just finished. I think I've left you just one part, that is integration, and a little bit of logarithmic and exponential function. Okay. So in next class, we will start third chapter, the motion straight line.
Okay, sir. Thank you, sir.
Okay then, thank you.
Sir, should we do this some as a homework?
Yeah,
Okay, sir. Thank you.
thank you.